Okay, as I was helping my face-to-face classes with questions about Kaggle, I thought I'd make you guys a little video to cover some frequently asked questions that I'm getting from my students that I'm seeing in my office or in class about the Kegel project. So if you go to, this is just going to help you get started in Kaggle. So if you go to our page in Canvas and click on Exam 3 Material and scroll down to the link for the Kaggle project, Project 3, Kaggle Predicting Home Prices, it's going to take you to the description for the assignment. So click on this link that's embedded in the explanation for the assignment, and it's going to bring you to the Kaggle platform. Now, if you don't have a Kaggle account, you're going to create your account here, but I have one, so I'm going to go ahead and log in. All right, now it's going to take a second to load because I'm recording and that takes a lot of bandwidth. So, but it's going to dump you into a main page for Kaggle, and the easiest way to find our class's specific competition page is just to go back to Canvas and click that link again. And this way, once you're logged in, it will direct you directly to our competition. Now, when you first go into Kaggle, you're going to have a blue button up here at the top right that says Join Competition. So click that and accept all the rules, and then you're going to get the submission buttons up here. Now, you want to create your team in Kaggle. So you already have your teams formed in Canvas, but you need to mirror those in Kaggle. So if you have the team tab, you're going to click on it. If you don't have the team tab, just go over here to the Submit Predictions button and pretend like you're going to upload something. Just click on the Upload Files, grab any data file that you have on your computer, a PDF, anything like that, and just hit Make Submission. Now you're probably going to get an error message at the top because your file's not going to be formatted the way that Kaggle wants it, just like this. It says failed on mine, but that doesn't matter. Refresh your screen and then you should have this team tab. Now once you have the team tab, get one of your team members, just one, to edit the team name starting with your section. So that's OD1 for Online Delivery 1 and a dash, and then do your last names separated by commas, preferably in alphabetical order. This really helps me when I grade. All right, and then save the team name. And then the other team members are going to go down here and you're going to type in OD1 to search for your team. Now, you guys didn't start your teams yet because I'm just giving you this introductory video. So I'm just going to type in 008 for my other class. And you can see that we've got a lot of students in those classes that created their teams in here. What you'll do is you'll type in OD1 and then you'll scroll through the list until you see your team and you'll request a merge. And then your team, the person who created the team name, can accept the merge. All right, once you've got your team, you're ready to make predictions. So how do you make predictions? Well, you're going to read through this page carefully in Kaggle. I'm not going to read it for you. I know you can read it. But you're going to scroll down to these two links. You're going to click on the train data set with the NAs removed and the test data set with the NAs removed so that you get them in your downloads folder. And then you're going to go to R. All right, so I'm opening up R and I've sent you a script file. So it's attached to the announcement that I sent with this. And I'll also link it in your assignment. But anyway, you're going to do File, Open Script on a Windows, and on a Mac it might say Open Document. But click on that and you're going to open your Kaggle script. So I think mine's on my desktop, and then I have to change this little drop down here on the bottom right to All Files in order for it to find it. So wherever yours is probably in your downloads. Mine's on my desktop. I'm going to double click on it to open it up. So now notice that I've got the GUI that you guys were used to working in R, the main page that you type commands into R. And then there's also another window open called the script editor. Now pay attention very carefully to this one. This is where a lot of students are making a mistake because they're not listening carefully. Highlight the first 3 rows of your script file. And in a Windows machine to run that, you're going to click the middle square over here on the top left of your screen. And on a Mac, once you've highlighted them, you hit Command and Return. Now I'm going to run my code and I get a pop-up. And notice here on the left, this first pop-up is asking me to click on my train file. So I'm going to go to my downloads and grab my train file. Train NA removed, and I'm going to double click on it. And now notice it's trying to run this second line where it's looking for the test file, and it's opening my window to search for it. So I'm going to click on my downloads folder again and look for my test file, and there it is. I've got downloaded it a million times. And then notice that it attaches the train data set for you. Don't attach the test data set, only attach the train data set. Just copy and paste all my code. So now we need to decide what model to fit. Well, we've learned simple linear regression previously, so I propose that the first model we fit just to learn how to make predictions in Kaggle is just to fit a simple linear regression model. Now I'm calling my fit statement fit, and I'm using my LM function just like in simple linear regression. And my response variable is sale price. That's always going to be your response variable. And I'm regressing it on the square footage of the home. Now, how do I know what columns are what? Well, first, I can look at the structure of my train data set by using str and then open close parentheses around train. And it'll tell me every column in my data set. So there are 80 columns because we have 79 possible predictors, and your response variable at the very end, sale price. Okay, so I've got all these different possible predictors to choose from, and I chose the square footage because it seemed like a natural baseline predictor that would be important to a home buyer in determining price of the home. Now, to learn more about which predictors are what, you can go to the Kaggle competition and click on data, and you'll have a description of every single column. So definitely read those. You might want to, if you've got real estate professionals in your family or a friend, you could ask them what they think is important. You can Google it, or you can just go with your gut and try, okay, to build your best model. All right, so once you pick out what predictors you want to use, you go ahead and fit your model. So let's all use the simple linear regression this time with square footage. So I'm going to run that code, and then I'm going to look at the summary of my fitted model, and you have to spell it correctly. And we can see that the standard error of this regression is 56,000. So that's not really great, because that means that sales price predictions are going to tend to be off by $56,000 using this model. So obviously using this one predictor model is not going to be good. Also, the R squareds are only about 50%, so we're only explaining 50% of the variability in sales price using living area, the square footage of a home, as the predictor. But anyway, let's pretend like we're happy with this model, and we want to go ahead and put our submission into Kaggle. So you guys can feel free to just do this. Wasting one prediction on practicing is not going to hurt you at all. So go ahead and highlight the next 4 lines in our script editor. And it's okay to highlight the line with the hashtag in the front too, because R ignores anything that comes after a hashtag on that line. And so again, on a Windows machine, I'm going to click this middle square button. On a Mac, once you have it highlighted, you hit Command Return, and it runs the code. So what does this code do? Well, I've created an object called submission in R, where I binded columns together, column bind, cbind. I binded together the ID column in the test file with the predicted values of the test file based on the model that I fitted on my train file. So I've created an object with 2 columns. And then I gave it very specific column names, ID and sale price, exactly the way Kaggle wants it for submission to their platform. This other function is new to you as well, the write.csv function. You've learned read.csv, where you're reading in a CSV file from your hard drive, say. Well, a write.csv writes a CSV somewhere. So I'm telling it to write the submission object into a CSV file called upload.csv on my computer. And you have to use this row.names equals false so that R doesn't append its numbered lines. at the beginning of your object. And then I tell it to get my working directory. So my working directory here on this Windows machine is on my C drive in my Documents folder. So I can simply go to my Documents folder and look for the file called upload.csv, and there it is. I can open it up and take a look at it. Now on a Mac, it might not be super intuitive where that file was stored based on that working directory. So what I recommend is just typing in your search area the full name upload.csv, and then tell it to search your whole Mac or all files, and you should be able to find it that way. All right, and when I open it up, I can see that I've got my 2-column CSV file, one called ID and the next one called sale price. So exactly the way that Kaggle wants it, and it's got all of my predicted values all the way down the 1,459 homes that you were supposed to predict home prices for. So as you can see, the hardest part of this project is figuring out which model to fit, because once you add your predictors that you want and reduce your standard error and raise your R-squareds, and you're happy with your model, then you can just run my code and it'll automatically create this upload file in the right format for Kaggle for you. All right, so I'm going to close out of this. Now we've got our upload file and we want to upload to Kaggle. So what do? We go over here to the Kaggle tab and click your blue Submit Predictions button. Scroll down to the upload icon. Navigate to the upload file wherever you stored it. Mine was in my documents. And now the second part is very crucial. On every submission that you make, I want you to paste your fitted model statement. So you'll just go back into R and scroll up wherever you fitted your model. Oops, I passed it. Just copy that fit statement. Some of these are going to be quite long because you're going to have lots of predictors in your model. So just grab that fit statement and paste it here so that I can recreate your submission if I want to. And then click Make Submission. And this time you won't get an error message. Everything should look hunky-dory. However, and you'll see where you are on the leaderboard. So you can see that my other classes that I got started on Wednesday are making predictions. So this group is at the top of the leaderboard. They've got their root mean squared log error down to 0.15, which is really good. And that's after only 10 entries. Okay. This other team has been busy with 40 entries. So it's nice to see people working on this project. You should be able to you can see that we've got lots and lots of predictions. The one that you're submitting with just the living area as the predictor is going to have that score. We all have the same score, so don't keep there. I'll know you didn't do any work if that's the case. So part of your grade is going to be your number of entries. And so read the announcement and the rubric that I'm going to give you. Remember that you can only make 10 entries per day, so you'll want to start early. I want you thinking early and often about your models, because you'll have little aha moments and you'll think about other things that you can do to tweak your predictions. As you're going through the video lectures, you'll get other ideas, like when we learn how to add quadratic predictors. You can look at the rest of the code on the script file in R, and I've written script for you so that you can just run it and get a scatter plot of every possible predictor against the response. Now, if you're working on a Mac, if you're working on a Windows, this code will run perfectly. But if you're working on a Mac, win.graph will not work. So you either want to put quartz with open close parentheses here or dev.new open close parentheses. One of those should work on your Mac. So I'm going to leave it as the win.graph, and I'm going to go ahead and run it and show you what it does. So what I did was I just wrote a little loop, and I got R to dial up every single scatter plot for you. And as you're going through the scatter plots, you're going to see that some variables look like they have a relationship with the response, but it's not linear. So you might want to try a transformation. And we cover that when quadratic predictors and things like that when we get to that part of the lecture, when you get there in the lecture videos. So as you think about these every day, you'll have little aha moments about things that you can do to try to make the fit of your model a better one. So that's why the idea is to have you start early and think about this over multiple days so you can really learn and grow and formulate really good questions for me and get good ideas as you're working on your project. So we've covered the code, we've covered the predictions, we talked about how to look at the leaderboard, and you should be ready to go. So you can send me questions, come in and see me in my office hours, and good luck making predictions.